Now I want to just talk a little bit about proprietary technology and open source technology, the differences between them, what they mean, and the implications of that. So proprietary technology is just anything you have to pay for, basically. Some common examples include operating systems like Windows or Mac OS, programming languages like MATLAB or VBScript, software packages like Microsoft Office, so Word, Excel, PowerPoint, Adobe Illustrator, um, or ArcMap, or ArcGIS Pro. So what makes something proprietary is that one, you have to pay for it, and two, the source code is closed. That means that it is protected under copyright. Users don't necessarily have a right to view, access, edit the source code. You can't see what's going on behind the scenes of these different software or operating systems. And so it's pay to play. Users are required to purchase a license in order to gain access. So software licenses can often be quite expensive. For instance, ArcMap, which is the sort of cheaper version of ArcGIS Pro, is on the order of hundreds to thousands of dollars. License for ArcGIS Pro is going to be even more than that. So generally, unless you're a member of some sort of large institution like UBC, or you work for, say, a government organization or a large firm or something, you won't necessarily be able to access these software packages. So, I mean, Microsoft Word has a family or a student version that's, fairly cheap, but ArcGIS Pro is going to cost you hundreds and hundreds, if not thousands of dollars. And so this can be a big issue for restricting access to information, who has the ability to analyze certain information, who has the ability to produce certain information, interpret it, work with certain maps. It can be a big issue. So some of the pros or advantages of working with proprietary software is that usually they're paid support workers. So it makes it easier for non-expert users to get help. And usually things are pretty thoroughly documented. So for instance, in some of the early labs, I linked to the Esri documentation pages for examples on how to work through some of the tools. And so they usually have a site that's pretty well built up with lots of information. They've got tutorials for new users. So you used that in lab 1, for instance. And generally speaking, the user interfaces are pretty well designed. They're made to be user friendly because, generally speaking, they want to gear them towards non-expert users. Some of the cons, again, the access of the source code is restricted. So bugs aren't easy to fix on your own. Things aren't customizable. I've run into issues with this with ArcGIS Pro, for instance. And so in order to try and fix something, you have to go through a formal channel, make an error or bug report to Esri, and then just kind of sit and wait and hope they maybe decide to address it. But you can't really do anything about it if they don't. Many times it's tied to a specific operating system. So for instance, if any of you are using a Mac, you might have encountered the fact that ArcGIS Pro doesn't work on Mac OS. You either have to download a Windows partition or access it remotely through the UBC lab. Either way, it's kind of a pain, causes issues. And most importantly, it's expensive. So again, it restricts access to who can use the software. If you are not well off, you don't have considerable resources, you're not part of an organization, you are excluded from the ability to use this software just based on your lack of financial resources. Good alternative to that is open source technology. And so common examples of open source technology include operating systems like Linux or Android if you're working on a mobile phone. Most programming languages are open source, so Python, R, Java, the ones that I've talked about. And then various software packages. So for instance, LibreOffice, which is the Linux equivalent of Microsoft Word. Inkscape would be the alternative to, say, Adobe. And then there's QGIS, which is a GIS software package that is essentially the equivalent of ARC. And I'll show you a little bit about that. It's basically like somebody copied and pasted ARC and put it on the internet for free. So if any of you want to work with that down the line, I strongly encourage you checking it out. And I'll show you how to access it in just a minute. And so what makes open source technology special and different is that the source code is open. Users have the right to view, edit, and distribute it. They can modify it, change it. This is great for crowdsourcing bug fixes, for disseminating information more widely, openly, accessibly. It makes updating and changing things easier. And they're free to use. So open source software is more accessible because of this. Anyone with an internet connection and a computer can work with these software packages. And granted, that also has some barrier to entry just by virtue of necessitating needing a computer and internet connection, but at least it's about as equitable access as possible for GIS software. And so it makes it a lot easier for individuals who aren't a member of organizations or organizations that don't necessarily have the funds to pay for these expensive licenses. It makes it easier for them to still do GIS work, for instance. And so the pros of open source software are that the source code is accessible. That means it's fully editable and customizable. Users can write custom scripts. So for instance, GIS uses plugins where users can write custom programs similar to like tools in ArcMap. It's not tied to a specific operating system. So for instance, QGIS works on Mac, Linux, or Windows. And most importantly, it's free, so anyone with knowledge of the field or subject can get access to it. So most importantly, it is a powerful tool for making information more accessible. Some of the cons are that support is generally from expert volunteers. So like you have to go on forums like Stack Overflow, for instance, which I linked to in Lab 4 in regards to Python. There's also QGIS help on there. So generally speaking, it requires the user to be already a little bit familiar with the subject matter in order to access the help in the first place. And sometimes the help can be a bit abstract and difficult for inexperienced users because, again, these are people who aren't being paid to offer their support, so they might not give as detailed of an explanation as, say, a help support worker for Esri. And sometimes, although this isn't so much the case anymore, it's more of a historical thing, the user interfaces generally aren't quite as well designed as, say, the pay-to-play software packages. So let's just take a look at QGIS for a moment. QGIS is really easy to access and download. If you just Google QGIS, the first hit that comes up is this QGIS project. You can open it, and the latest release is 3.18. It's easy enough to download. You just click this, follow the steps. And so you can pick the distribution you want and download it from there. So this is QGIS. Here we have just an empty project. It looks very similar to ArcMap, which is like the older version of ArcGIS Pro. So it's pretty easy to use. Like we've got this browser on the left, which is very similar to the ArcGIS catalog or the ArcPro catalog. For instance, I've navigated to the Lab 4 folder and just found this census data layer. It's really easy to just drag it in. It's in the WGS 1984 projection right now, but if you want to change the projection, that's very easy to do. You just go to Properties. You can search for the projection in this bar. See Albers. It's actually easier to search for and find projections here than it is in ArcGIS. Change the projection really easily. If you want to display the data differently, you can go to Properties and say Categorize or do Graduated Symbology. If you want to say Display by Value 1, the total population, you can classify the data, click Apply. You see you'll classify by population numbers, for instance. You can change the classification methods. So you can do equal interval, natural breaks, logarithmic scale. There's a variety of different things you can do with this data, just as you would in ArcGIS Pro. You can do different vector manipulations like buffers, clips, dissolves, different types of analysis. There's raster analysis. It has raster calculator. You can change projections of different layers. Lots of different types of things you can do. So this software is more or less like someone copied and pasted ArcGIS and put it online for free. So if it weren't for the fact that for some reason the department wants me to teach you Esri products, I probably would have just taught the whole class using QGIS instead. I personally think it's a much more equitable and accessible way to use GIS than, say, being beholden to a very large corporation like Esri. Additionally, Python is open source, and I've already showed you an example of that. You can also do GIS in R, which is another programming language. So you have lots of different options in terms of pursuing open source GIS.